Hello everyone. Today we are going to see a new DFA problem. Draw a DFA to accept the strings of A's and B's having not more than 3 A's. Okay. So our main condition is not more than 3 times A. Means our machine should not accept a input more than 3 times. Okay. So as usual, we'll start with the Q0 state. So this is the first state. Okay. So we'll give the first input A. Okay, that is one input A. So again we'll go to the state Q1. Again we'll take one more input A. Again we'll go to the state Q2. Again it can accept one more A. After 3A we need to stop our machine. For that we'll again write a Q3. Okay, but what happens, they're saying it is not more than 3A. Means it can support 1A, 2A and 3A. After 3A it can't go to the new input. Okay, so this is the basic condition. Now we'll plot into a transition table for our convenience. So I will plot. So we have states that are Q0, Q1, Q2, Q3, and we have a two set of inputs as mentioned in the question. One is A and one is B. So we want to do for all the combination of A input and B input. So Q0 on A, it goes to Q1. Same way Q1 on A, again it goes to Q2. So again Q2 on A goes to Q3. So remaining states is not yet defined. We will check out how to do that one. So we'll start with again Q0 on A, we go into Q1. So for a B there is no any restriction on condition. There is no any condition to start with or something like that. So what we'll do the self loop of B. Means it can loop any number of B's, or it can directly start with the A. Means the machine can accept the B input as the first input and any number of times it can accept. Otherwise it can directly start with a 1A. Okay, so then we'll fill the table, that is Q0 on B goes to Q0 itself. Okay, now we'll see the Q1 state. Now we want to plot it for Q1 state on B input. Q1 state again on B input, it can also do a self loop. Any number of times we can self loop the B so that it does not change our basic condition, that is not more than 3A. Again same way for Q2 also we can loop any number of times of B. Okay, yes. After Q3, same way Q3 also we can have any number of times B. There will be no problem. Okay, now we'll plot into the graph, that is Q1 on B go to Q1 itself. Q2 on B go to Q2 itself. Same way Q3 on A, we are not yet defined. Q3 on B can go to Q3 itself. Okay, now after 3A, so our main condition is not more than 3A. After 3A we can't continue. So what we'll do, so we'll define the final states first. Or we'll define the final state. After 1A our machine can stop. So we'll make this one as a final state. After second A our machine can stop. That will also will make a final state. After third A we can stop our machine. Okay, and one more condition, without A also our machine can stop and work. That is, we'll make the Q0 also as a final state. Okay, now the left out is we don't have a condition for Q3 on A. So now what we'll do, we'll create one more state, that is from Q3 if you goes to A, you'll go to one new state, that is Q4. Okay, so that will act as a dead state. Okay, and it can have any number of A's and B self loop. Okay, we can call it as also trap state. After 3A, if it is goes beyond the 3A, it will go into the trap state. Whenever it go to the trap state, from that we can't come back to the final state, any one of the final state, to stop the machine. So that it goes continuously into the trap state or loop state. Undefined time our machine will not stop until our machine stops, we can't accept our input. Okay, therefore Q3 on A goes to Q4, and we want to add new state, that is Q4 on A again goes to Q4 itself. Q4 on B goes to Q4 itself. Thank you for watching. Subscribe and like for more such videos.